Now it's time to check how we can choose the position of our equipment. In most simulation, the new position is choose simply the direction, up, down, left or right. But with our rules, the movement angle and distance need a set combined movement. For choosing new coordinates, we optimize the horizontal and vertical speeds. This way UAVs can reach all the possible positions continuously. Now we want to look more closely at the how optimize choose the positions. For example, let's think of this initial position. First of all, the algorithm consider what the score current position has. Then choose a nearly random position and calculate the score of that position. It keep doing this and test different position. At the end, the optimizer choose the position with the best score as the new position. Then the simulation move to next time step, where the user have a move to new position. Up to this point, we check the different parts step by step. Now, let's take a look at the overall view of how this simulation works. First of all, load the map. Then we set the time step we are in. Then we ask the optimizer to find the best position for the UAVs. The optimizer finds the speed, so they must be converted into positions. And finally, we save the data. Let's also take a look at the optimizer, because some of important comparison data comes from inside the optimizer. First, it considers some initial speeds. For the optimizer, we use 10 particles. Then it's converting them into positions and it calculates the scores. It saves this data because it's important to see how fast improve in choosing the optimized position. This process is repeated many times, about 300 times, and finally the best position in chooses. Let's take a quick look at what optimizer exists and which one to test it. There are many types of the optimizer algorithm. Some of are evolution inspired by biologic. Some are physical based using natural laws. Other are swimmer based like a PSO or ACO, and some are human based copying, learning and behavior. Now let's focus on the optimizer that was tested in our works. Particle Swimmer Optimizer. This method inspired by the why birds move in groups. Grey Wolf Optimizer. GWO inspired by the hunting behavior of the gray wolves. Wall Optimizer Algorithm. This method copies the why walls hunted with the bubbles. Improve PSO, HER2 values omega and C change during the runs. GWO and PSO, this method mixes the PSO with the GWO. 10th PSO, this method PSO with the 10th chaotic map. Now we move to the results section. Here I will show the outcomes of our simulation. This is the UAV's movement map, but it does not look very realistic. So, let's use the path smoothing algorithms to make the trajectory more realistic. The results looks good, but if you look closely algorithms find almost the same path. Still, the patterns are slightly different. We will discuss the reason for this in the future. Need closer look at the reviews the scores. First of all, we monitor the optimizer score at the ever calculation of the optimizer and the each time step. Then we took the average of all the steps. Then we placed the results of all optimizer for each mode side by side. 5 different modes were executed and for each mode the calculations were done. In the end, we took the average performance of all modes for each algorithms. So, the final result of fit total and the fits that had a positive impact are important for us. According to the results, 10 PSO our reached positive outcomes very quickly. There was a problem in path selection that we mentioned before. Now, let's take a quick look at this problem. The start of the each time step depends on the optimal choice from the previous step. For this reason, if the optimizer gets stuck in the local minimum, it's also very important to consider how much time the optimizer takes to finish the calculate. This is the important key for the real-time system. We have come a long way so far, but most of what we discussed has been basic concepts, serving an introduction to our research. We are still working on areas that can have a stronger impact. Thank you for being with us. The supervisor of this project, Dr. Khan Kalantari, and I am Mohammad Hussein. I hope the future we can present even more exciting topics.